Okay, concept 26 is the unit circle, and the first thing we need to do here is fill the circle in with all of the radian and degree measures. So let's start with degrees. Here we start at 0, and each of these larger gaps is going to be 30 degrees. So here is 30 degrees. Each of these smaller gaps is 15. So that would give us 45 and 60. Another big gap gets us to 90. Another big gap gets us to 120. And these would be 15 more, so 135 and 150. Plus 30 is 180. Plus another 30 is 210. Add 15 again. Plus 30 is 270. Plus 30 is 300. Add 15, and add 30, which gets us back here at 360. We also need to label the radians. So one way we could do this is to picture this unit circle split into twelfths. We know that halfway around would give us pi radians. And if we were to split this top half of the circle into twelfths, this spot, the spot where no angle is labeled, is the first twelfth. So this would be the first twelfth. This is the second twelfth of pi. So we have 2 pi over 12, which reduces to pi over 6. This is the third twelfth. This is the fourth twelfth. 5 is not one of the angles we need, and then 6 over 12. So if we reduce each of those, this is a fraction of pi. So 2 twelfths is 1/6, 3 twelfths is 1/4, or pi over 4. 4 twelfths is 1/3, or pi over 3. 5 twelfths is not labeled. 6 twelfths is 1/2, so pi over 2. And then we're going to go through the rest of the circle and label all of them. Here we have 7 twelfths, 8, 9, 10, 11, and 12. So 7 we're not going to label. 8 twelfths is 2/3 of pi. 9 twelfths is 3/4 of pi. 10 twelfths is 5/6 of pi. And 12 over 12, this should be a 12, is just 1, so 1 pi. The 11 we're not going to use. Then we get 13, 14, 15, and so on. So let's reduce all those. 13 we're not going to label. 14 over 12 is 7 over 6. 15 over 12 is 5 over 4. 16 over 12 is 4 over 3. And then 17 over 12 we're not going to label. 18 over 12 is 3 over 2. 19 we're not going to label. 20, 21, 22, 23, 24. So these last few, 20 over 12 reduces to 5 over 3. 21 over 12 reduces to 7 over 4. 22 over 12 reduces to 11 over 6. And lastly, 24 divided by 12 is 2. So this would just be 2 pi. So if we look at these statements in problem 2, which statement is not true? So we're looking at sine versus cosine in quadrant 3. So here we're in quadrant 3. The statement is sine and cosine are both negative. Sine is always negative below the x-axis, so that's true. Cosine is negative to the left of the y-axis, so this is true. Quadrants 2 and 3, so here and here, cosine is negative. Cosine is always negative left of the x-axis, so this is also true. In quadrants 1 and 4, so here and here, sine is positive. Sine is positive vertically in quadrant 1, but sine is actually negative in quadrant 4, so this is not true. And then in number 3, we are labeling the coordinates of the points that are labeled here. What that means is we're trying to find the lengths of the legs at each of these points. So at A, the x value is this long leg, and it's in the negative direction, so negative root 3 over 2. And the y value is the shortest leg, which is also negative y direction, which would be negative 1/2. Point B up here, we are at 0, 1, because the radius of the circle is equal to 1. At C, the x value is the medium leg, which is positive, so root 2 over 2. And the y value is negative, also the medium length, so negative root 2 over 2. And then lastly, point D, the x value is the shortest, and it is in the positive direction. And the y value is the longest in the positive direction, so root 3 over 2.